So the next problem we're going to be doing is about some ants and a giant pile of sugar. Basically, there starts off with 21 ants, and there's a 19% growth. So we need to figure out the exponential situation that models this. 19% growth, that's the multiplier for it. It's 100%. We get everything that we have back, and then additionally the 19%. And so then that's to the x power. We always write it in that form. If it was 19% loss, remember the equation would be like if we were like modeling how much sugar there was. A 19% loss is actually 0.81 for a multiplier, right? Like if you lose 19 points on the final, you would have gotten 81%. This means 81% of the total amount remains each time. So this would be 19% loss, but we're not doing that situation. This is the situation we're up to. So then they ask us a couple questions. They say, okay, after 15 minutes, how many ants are eating off the pile, and when are there 800 ants in the room? Both of these you can make a table with your calculator or to solve, or you can, at least for the 15 minutes one, you can plug in a 15 for x to arrive at the solution. The 800 ants in a room, you'd have to know logs to figure out, which isn't something we cover in Algebra 1. So that one we're kind of stuck making an estimate off a table for now, but soon you'll get an exact answer for that. Okay. So then we started going into recursive form. Get out of here. This is number 8 on your worksheet, and I know the number is a little bit off. So here's recursive form. This one is 50, 40, 30. Now, recursive form, remember, just has two parts that I need to satisfy. I need a starting value, which is like 50. If you want to start at a sub 0, there's no difference, right? It's just as long as you you label it where you start, right? You can either start at a sub 1 or a sub 0. I'm just going to start at a sub 1 because whatever. Here's the second part you need. So this sequence starts at 50. What's happening each time? It looks like I'm subtracting 10. So to get to the next term, I take the term before it. That's what that a sub n minus 1 means. And all I'm doing each time is subtracting 10. Now remember, this part down here is just notation. And it doesn't mean that I'm actually subtracting 1. That just means the term before the term I'm actually trying to find. So these both are the recursive form for that sequence. So this would be part B then of that same problem. What if it looks like this? Now this looks like an exponential one, right? Same thing, I start off at 10. How do I get to the next term? To get the next term, I basically take the term before it, right? It's the same style. And I'm going to multiply by 2 each time. So recursive form, I just need those two parts. Moving on to 9, they give me the same two sequences. And this is how I write those ones. One of them is arithmetic, and one of them is geometric. Remember, arithmetic grows by addition and subtraction. Geometric grows by multiplication or division, right? Or I guess decreases by. So the way that you write the first one, it's like linear, right? It's going down by 10 each time, a set amount. So if I was to write this as a linear equation, I would say my slope is negative 10 and I start at 50. Well, to write that as a sequence, I just say a sub n equals negative 10 times n plus 50. This is the amount that I change by, and this is my starting value. So in explicit form, I do it like that. Same thing for the second one. If I was to write this one looks like it's an exponential situation. If I was in the exponential chapter, I would say I'm going to start at 10, and I'm going to multiply by 2 each time, and that's going to be to the x power. That's how I'd write the equation. Well, it's really similar for my explicit form. I just want to do it like this. Right? So this would be the answer, the solution for that. And I just realized I'm writing off the page. So let's do that again. So it would look like this, right? 10 times 2 to the x. That's how I'd write it if I was in the exponential chapter, but with this, I want to write it like that. Now we should be good. Okay. So moving on to 10, I want to find a sub 6 for both of these. Or a sub 5. So for 10a, they tell me a sub 1 is 4, right? Actually, I'll do it like this. A sub 1 is 4. They give that to me as the starting value. And then they tell me how to find each additional one. They say it's 2 plus the term before it. So a sub 2 is 6. I'm just adding 2 each time. So explicit form is, recursive form is nice for a lot of different reasons. It's kind of a pain on these ones because you have to write out the sequence. But we get there. We figure out that a sub 5 is 12. It's no big deal. We just got to start counting by 2s each time. But when I do the explicit form, you'll see how much nicer explicit form is there. If I want to find a sub 5, so that n becomes a 5. Explicit form, I can just skip right to the solution. Skip right to the solution by plugging in a 5. So if I was to do that, let's see if I get 5 times 1 point to the 5th. I got 8.05255. And that should be your solution. So you can skip right there. Okay. Lastly, let's finish this packet up. The last problem, they tell me a sub 1 is equal to 0. Once again, I'm going to do it like this. Is equal to 0. A sub 2 is equal to 1. So this is 11. They want me to figure out all the way to a sub 5 if this is the rule. So this is the key part right here. I take the term before it, that's what that means. I add it to the term that's 2 before it, that's what that one means, and I square it. So to find the next term, I take the terms that are 2 before it, and I add them together, then square. So in this case, I take the 2 terms before it, 0 and 1, add them together, it's 1. 1 squared is 1. Okay? To find this term, I take the term before it and the term before that, add them together, 2 squared is 4. So to find this term, I take the 2 terms before it, 1 plus 4 is 5, 5 squared is 25. So this establishes the rule to find all the next values. Okay, so we're done with that packet.